Hey guys, this is chapter 6 plus matrices. I know I didn't get that onto the live stream, so I want to do this now. These questions from the matrix and from the chapter 6 is from the worksheets that are attached to this this Google Classroom post. So let's first do some chapter 6. Number 1, we'll do number 1, 6, choose 3. Now you could do it in your calculator by just going into math. Go to the right to PRB, probability, and then go to NCR. Now for mine, I have to put in the number first. Some of you get like a nice system where you can put in the number separately. So 6, choose 3, that's 20. If you want to do it by hand, it is 6 exclamation point over 3 exclamation point over what is 6 minus 3? It's going to be 3 exclamation point. So that's going to be 6 times 5 times 4 times 3 times 2 times 1 over 3 exclamation point is 3 times 2 times 1, and 3 exclamation point is 3 times 2 times 1. Well, these cross out. You see all this is exactly the same, so that crosses out, and 3 times 2 equals 6. So then that's going to be 5 times 4, which is 20. I'm trying to move these books a little bit to the right. Okay, so that's 20. So that's the answer for number 1. Let me just put number 1 here. Let's go to number 3. Just how do we set it up? Well, it is, you know how to make 7 type of cookies, so there's 7 in total. And you have to make 4 of them, so there's 4. So how do we do that? So you just 7, choose 4, using the calculator again, because I suggest just using the calculator. Why play it dangerously? If you make a mistake, just play safe and use the calculator. 7, choose 4, that is going to give me 35. All right, let's go to the next. Let's see what we could do. Number 4 will not give you an expand problem, so don't worry about this. Number 5. So number 5, please change the question. I attached this. It says 2 queens and 3 aces. Let's turn it to 2 queens and 3 non-queens. Because if you do with aces, you have to do slightly different. Or you have to do. So what is 2 queens? So how many queens are there in the deck? Well, there's queen of hearts, queen of diamonds, queen of spades, and queen of clubs. So that is 4 queens, and I'm choosing 2 of them. Times how many non-queens I'm getting? Well, how many non-queens there exist? There's 52 minus 4, that is 48. And I'm choosing 3 of those. So in the calculator again, you simply go to do, and I'll put it in parentheses just to play safe. Give me a second. So parenthesis, this is 4, math, NCR 2, I'm choosing 2 of them, times parenthesis. You might not need to use the parentheses depending on what calculator you're using, but I like to use it because it just lets it be less errors. That's why I do it. So please, I suggest using the parentheses. So 48 NCR 3, close parenthesis, enter. So it's just some big number like that. Let me just check again. What is that? 103776. So it's just some, that's how many possible combinations you have of cards. Okay? Let's keep going to chapter 6. Okay, so the distribution curve. How does it work? You have to remember these numbers in the curve. They're always the same. Let's make it solid on this rush. So the first 2 numbers in the middle is 34 and 34. The second 2 numbers is 13.5, 13.5. This is percents, by the way. This is going to be 2.35, 2.35, and this is 0.15, 0.15. So those are percentages. Now, the middle number is going to be your mean. So for question number 6, your mean is 40. So the number underneath is going to be 40. And your standard deviation is how much it goes up and down by. So for this, it's going to be 44, 48, 52, and that'll be it. Over here will be minus 4, so 36, 32, 28. Okay? Okay, so that's how you fill out the curve. Let's do number 7. Number 7, what is between 32 and 36? So we could actually look, 32 and 36. So we need this area right here. That is just 13.5. So for number 7, is 13.5. But what happens if it's not on the curve? And you could use this calculator method if it's not on the curve. Like number 9 less than, x is less than 42. So how are we going to do that? Well, we're going to our calculator. Let me clear the screen. You're going to second vars, which gives you distribution. Normal CDF, only CDF. We never use PDF. Lower number. So we're going less than 42, so we want a really small number. I already have a really small number, 0.001. What's my upper limit? That's how high I'm going up to. So I'm going to go to the maximum, which is 42. My mu, which is our mean, the mean is from the previous problem, so that's 40. And the standard deviation, that is from also from the main problem, which was 4. You click enter, paste, and then enter again. You get 0.69. So your answer is 69 let's do a little bit more accurate, 69.1%. So that's how much percent is in 42 or less. Okay, 10 is the same type of problem. So let's go to 11. 11, this is newspaper sponsoring poll wants to find the preference of farmers across the state regarding the state's governor election. It goes and asks every third farmer. So since you're learning about farmers and you're asking farmers, there's no bias in who you're asking, and the question doesn't seem biased at all. So I'm going to say it's a non-biased question. And then with that in mind, how do they do it? It's every third farmer, so that's systematic. Because it's every third farmer. Number 12, let's see. A movie theater wants to see if the average person is going to the movies. They ask people who buy tickets at their movie theater if they watch movies. So if you're trying to learn the average person and you only ask moviegoers, you're going to get a skewed thing. So that is biased. And since you're asking at your own movie theater, so only your location, that is convenience. There's also random. That's usually computer generated or names out of a hat. And there's also self-selected. That is like survey and such. Okay? None of these are necessarily biased or non-biased. It's based off the question. Let's do number 13. Number 13, find the margin of error. So the formula for margin of error is capital M equals 1 over the square root of n, plus or minus. So the margin of error should equal 1 over the square root of 1600, plus or minus, which is the same thing as 1 over 40, plus or minus, which is the same thing as, let me put it over here, 1 over 40, which is the same thing as 1, let me just check actually real quick. .025. But you want it as a percent, so 2.5%. So the margin of error is plus or minus 2.5%. That's number 13. And then let's go to number 15, which is on the back sheet. Or I guess if you're looking on the computer, just scroll down. Number 15 is the reverse. So I'm going to do actually number 16. I'll do number 16. So this is 4%. So 4% equals 1 over the square root of n. So I'm going to times square root of n on both sides, times square root of n. So that's a square root of n times 4%. Oh, when I do math for percents, I want to change it to decimal. So square root of n times 0.04 equals 1. So I'm going to divide 0.04. So the square root of n equals 1 over 0.04. So 1 over 0.04, let me just check what that is. Divided by 0.04. That's going to be n equals, the square root of n equals 25. So how do I get rid of the square root? You got to square both sides. So n should equal 625. So this covers chapter 6. I'll do another video on matrices right after this. If you have any questions, please come in with questions prepared. Do not just ask like general stuff.